Welcome back. Today we have a U5000 that was sent to me, and I also got a 5000 cap kit sent by the same person, so I'll be using this with this chassis. But first, let's open it up and diagnose what's going on here. That's very disappointing right off the bat. It's not packed well at all. But that's just how it goes sometimes. This is just sitting loose in here. So that traveled all the way from, where did this travel from? Let's see here. All the way from Pennsylvania. All loose in here like this. Yikes. Well, hopefully nothing got damaged or broken. Pots on the neck board. They seem all right. Let's put them all to center just for a baseline. Wipe them a bit. Put them to center. Okay. Looks like someone's already done a cap kit on this. They sent this to me to do a cap kit, but it looks like somebody, at least on the neck board, has already done a cap kit. These are absolutely all replaced, all Nichicon. Yep, this has absolutely been repaired, or, well, replaced, I mean, caps anyway. We've got, let's just take this apart here. Oh, jeez. No one's ever had, ouch, dang. No one has ever had this off the chassis, though. There we go. Got the G2 wire off of there. And that was tough. Let's get our focus wire out of there. There we go. Now we can get a little bit of a better look. You can see these got bent over. We can do that. Well, that's pretty good right off the bat there. Spread these out the way they're supposed to be. Yeah, I mean, that's not too bad. We do have some loose solder. Well, mainly this joint right here is all wobbly. And these, it looks like someone's kind of gone through here and done the super glue trick, because it looks like there's residue on here from glue or adhesive or something, but they all need to be reflowed. This solder is dull and gray and not shiny, so we'll have to redo all of this. But somebody has absolutely already done a cap kit, so at least that's working in our favor. Main board. I can already see lifted pads on the video header pins, video selection header pins. Remote board seems to have survived. Like I say, these are the nice pots that don't break or snap on you like the white ones do. So the remote pot seems to be okay. Remote board pots seem to be okay. Well, we got a crack in the connector here, but it still should work. I'll have to leave that hooked up so we don't make it worse. Yeah. But that should be okay. The socket is still on the pin, so. But if we look here, let's just get this out. Let's get this out, make sure there's nothing else in here. Nope, don't see anything. Oh, what the heck? What the heck is this? Never seen this before. What is the idea behind this? What is supposed to hook to this? To the best of my knowledge, nothing goes in those slots. Huh. Well, my confirmation has been achieved. This has a full, complete cap kit, including a filter cap. So all these caps are new. So somebody has already done that. That's good. Well, in the traditional sense of them already being replaced is good, but I don't know if they did a bad job or not, and I don't know what's wrong with this. This is still quite puzzling, and if we look here, the whole connector is burned up. This is the first one I've had that the connector is burned up like this. Now, I don't necessarily need to replace this. Somebody has already replaced this connector. Why they put these other pins in here, I don't know. I don't think these are actually populated. If they are, I'll have to look at one of my other U5000s and figure out what's going on. But you can see the connector here is all burned up. It doesn't necessarily need to be fixed, because as long as the header pins, the solder is secure and you can push this on there, it'll work. But if we look at the back here, you can see that we've got lifted pads already, and all the solder is very dull and dim. Oh, now you can see. Yeah, this is lifted here, which I can fix that. The rest of this is very dull and dim, and you can hardly see any. See these? You can see the header pins here, but on here you can't. So I don't think that they're all the way down enough or out through the board enough. And someone has reworked the HOT. It looks like right here, someone's reworked the HOT. And yeah, I mean, otherwise it doesn't look too bad. Whoever did the cap kit did a decent job cleaning up after themselves, and decent solder work, except for maybe what's going on here. I don't know what's going on here with that. But nothing that can't be cleaned up or fixed up. Let's zoom out here, take again, you push up off from the bottom, and as you push up from the bottom, you work yourself out. So if we push up from the bottom very carefully and then slide it out in here. My phone rang there, sorry. So yeah, so you just, you push down from the top and up at the same time, up and down, and then as you do that, you push from the left and it comes right off. That's how you can avoid damaging it and other things like that. I can see this resistor's bent over. All right, so it's dirty, but I'm not going to clean it on the video because I do that afterward, off camera. I'll get all this cleaned up and let it dry and everything, and then test it one more time before I send it back to the owner. But this video is these videos are more for technical repair purposes, not cleaning purposes. So, well, it appears to all be intact, albeit very dirty. Let's get this off of here. Ugh, jeez. Why did someone solder this to the board? Good Lord. That was tough to get off of there. I think this is a very long life U5000 with the evidence of this being burned up on the 25. This must have been in like let's see, this is 25 inches. Most likely a Cruisin' USA or something like that. It uses the medium resolution games. Medium resolution system. So everything appears to be intact. I don't see anything missing. Let me look up what's actually wrong with this. I probably could have done that beforehand. This was... hang on a second. Okay. I pulled this chassis out. Looks like new caps. Looks like the caps are like new. Also looks like someone did some shoddy work, but it looks good enough to be repaired, I believe. Blah, blah, blah. Okay, this is dead. I have 3 dead monitors sitting in the basement that are spares. The U5000, another one. So this one appears to be dead. Well, okay. I have no idea what these are for, but we'll get to those later, I guess. In the meantime, since this is supposedly a dead chassis, let's go ahead and do some testing on it. And there's a little blurb here that says vertical repaired August 17th of last year. So I don't actually know if it's dead. We have to assume that it is because that's what I was told. Let's start with the basics. Okay, R104. Let's set this back on here just for now. All right. Serviced by Amusements Plus Incorporated, 2011. Alright. Well, let's see Amusements Plus. Let's see what we can find here. Alright, R104, 10K to 13K. 10K, that's fine. Voltage regulator is right here. We should have 1.0 to this leg. That's perfect. And we should have a 0.6 voltage drop to the other leg. 0.5, that's close enough. Alright, and you see here the way I do this is this little triangle here. Negative here, positive 1.0, and our voltage drop. That's how you check that. So voltage regulator is good. R104, okay, switch mode power supply chip from leg 1, 2, 3 to 4. We should get our voltage drop, and 2 to 1 voltage drop. 1, 2, 3, 4, 5, 6, 7 to 8 should be 1.5. There it is, 1.4. And 1, 2, 4, 5, 6 to 5. Like this should be 1.7. Yep, there you go. Switch mode power supply chip reads good. Can't say if it works, but it reads good. We'll have to do our light bulb test, but that's everything in the power section. You should have to check for a dead chassis. So that's all good. So next we'll check Q703. If that's bad, we won't have any power. So let's test that. I believe we should have, it's this one here. I believe we should have 1.0 to this leg. 1.2, close enough. Then our voltage drop is the other way. So center negative, and this should be our voltage drop. Yep. Q703 checks good. HOT is going to be this guy here. We should get our voltage drop like this. Yep. And yep. Well, no explanation as to why it would be dead if all that checks good. Now this U701 here, Q703 actually feeds this chip. So if you've got all of this other stuff checking good and it's still dead, and by dead I mean you turn it on, you get nothing, no life, no activity, no signs of activity, nothing. HOT is not ticking, nothing is happening. You could have a bad U701 as well, because this is part of the regulation as well. But I haven't had that come across on the channel yet, so this hopefully maybe this could be the instance, but we'll find out. It just for your edification, is if you check all this stuff just like I did and everything checks good and it still has no power, you may have an issue with Q701. Or I'm sorry, U701. Want to put that out there. So I guess what we can do now is I zoomed in here because I want to show this that I saw, this right here. We'll have to make sure that that is good, but it appears that it is. Let's just jump right over to the next trace, and I don't even know if that's how it's supposed to be. I don't see how that's supposed to be connected like that. What is that? I don't know what component that is. That's that leg of the capacitor? Yeah, it's that leg of the capacitor. I guess it's supposed to be hooked to that. I'll figure it out. Anyway, okay. Sorry if I didn't have that in frame there. Well, all right. So I guess we'll check our, not that I need it for voltage or for power, but let's check our vertical circuit here since it was previously repaired. R303 should be 1.2 ohms. Uh-oh. Well, I need to check it on the bottom side. We're checking this resistor here. It's kind of oxidized on the legs. So let's check the bottom side of it here. R303 should be these two. Yep, 1.3. That's good. All right. D302 should be... Okay, D302 is, there we go, 0.5. That's good. Let's check our HOT is not shorted, but we can check R765 and R760 as well. These guys here, because you can have, those can take out the HOT even though it's not taken out. They can also cause voltage problems. So we'll check R765 should be 33K ohm. 37, it's kind of high, but I'm not going to say it's wrong, it's bad. And then this one, R760, should be 400 ohms. I think it's 100 to 400, depending on the revision of the main board. And we read 477. Yeah, I'm not worried about that either. So, okay, so those are good, which they would be if HOT is not shorted. Let's test our ARG. I can't read what that resistor is. Well, this one here is part of the vertical circuit as well, so let's just test it, see what it reads. As long as it's not in the mega ohm. 81, yeah, I think that's normal actually. All right, so next we can test D603. It should read this way for voltage drop, and it should not read the opposite way. If it does, the voltage regulator, I'm sorry, I see that every time. If it does read backwards, then the vertical IC is bad. Uh-oh. Vertical IC is shorted. Look at that. This is the way it should read. That's the way it should read right there. If I swap these back around and test it the other way, it should not read. So I think we have a shorted vertical IC. That's why I always check that, because I'll bet you we'll have one of these reading to ground when it shouldn't be. The only one that should read to ground, oh, wrong way. The only one of these that should read to ground, I think, is pin 5. 1, 2, 3, 4, 5. Yeah, so if we go to ground here, and we go to pin 5, there's our ground. That's ground. But if we go to 1, 2, 3, 4, that's our ground. 6, yep, shorted. 7, 8, 9, and 10. We got a short to pin 6. That should not be shorted. Vertical IC is toast. Well, at least we know we're going to have vertical collapse. I am not going to mess with it. Shut up. What do I have? Oh, that's one. Okay. I'm not going to mess with it now. Let's just go ahead, since everything tests good, except for that. Since everything for power, pardon me, tests okay. Let's go ahead and do our light bulb test, make sure that's good. If that's good, let's just power it up and see what we get. Because we're absolutely going to have vertical collapse because the HOT, I'm sorry, the vertical IC is no good. But yeah, otherwise I think I want to just experiment and see what happens and verify that we have collapse. But it's guaranteed to have collapse because that pin is shorted and it shouldn't be. So we'd have to pull it out and verify that it's shorted out of circuit or if it's something on the board. But in the meantime, before I actually turn it on, let's go over to the 15 kilohertz side of things because the connector is not burned up on that side. And let's just reflow. Let's just reflow these header pins. Well, you know, we're on the 15 kilohertz side, and none of these are bad. You got to remember to do this one too. But all of these look good. None of those are lifted, and the solder seems there. It's dull and gray, but it's all intact. So with everything testing okay for power, we're going to have collapse, or vertical collapse. We're going to have collapse for sure. But with everything testing okay for power, let's do our light bulb test and get it on a board and see if it powers on to see if it actually is dead. If not, if it does work and we have collapse, we will replace that vertical IC and verify that it's not shorted. And then we can test from that point. So let's get our light bulb test setup going here. Okay, light bulb jumpers. I need my 3 jumpers here. There they are. Light bulb. And let's pull the jumper out here. Again, the one you want to take out of here is this guy here. You want to take this jumper right here take this leg out of the circuit, pull that up out of there. And that's going to be right here. If you could even see, sorry about that. It's going to be right here. Still can't see. Okay, that should be up and out of there. Yep. All right. So let's take this out. There it is. Easy peasy. Now, let's hook this for the bulb on there. Let's hook this for our meter. And we're hoping that we have, again, with the 23 watt bulb, we're hoping to be about 125 or 126 on the meter, because that will translate to around 117 on when it's under full load with the actual monitor hooked up. So let's get our ground situated. Okay, this will go to our meter. We'll go to volts DC, and let's get our power hooked up. Okay, we don't want to be hasty here. Let's make sure we got everything ready. Power, we're on the right selection without the burned up connectors and pins. We have the thing lifted out, the jumper lifted out of the board. We're hooked up to read our B+. This is just for attaching our ground. This will go to our battery, I almost said battery, our light bulb. And not that this matters, but this needs to be hooked up for 15 kilohertz. So I think I just found the problem and why this burned up, or why the IC went out, because someone had the vertical sweep mod hooked up onto the white pin. You know, there's two connections here. A white pin that you actually have to have hooked up for 15 kilohertz, and a black wire here that's been cut off that you hook up for the 25. You want the wire hooked up to the pin for 15 and not hooked up to the pin for 25, and it was hooked up to the pin when it was set to 25. So that probably burned it up. So not that it matters now, but we'll put it back on the 15 kilohertz selection, because that's what we're going to test first when we go to test this, is the 15 kilohertz side of the standard res. So let's go ahead and flip this on here. 1, 2, 3, and we're going to be a bit low. We're hoping for about 173-ish or so. But right there we have B+ generation. That's B+ without a load on it. So if we were to do this, this will put a load on the B+ and bring it down to about 120, 124, I'm hoping. Let's see, 1, 2, 3. Yeah, we have a light bulb and our power supply section is good, but we're only 121, so I think our B+ under load will be about 115, maybe, a bit too low. But hopefully we can adjust that. It looks like maybe we can. I don't know, but we have good B+ regulation. Our power supply section is good. So now we can proceed on. Let's go ahead and disconnect all this. We need to discharge our B+. If we look here, we're still at 170 volts, so if we just like discharging the picture tube, you want to ground out the system. There you go, 0. And it jumps back up to about 2.5 volts. And we can see here, I can just go right back to 0. So yeah, we're good. Let me put this jumper back in. Then I'm going to grab another 5000 and see if I can figure out what's going on with this setup here. I don't know, does this have to hook together? No, they can't. They're the same spade connector. Let's get another 5000 and compare what's going on here, and I'll do some quick reflow work on some stuff that needs it, and then we'll just go ahead and power it up and see and verify that we have collapse, which I know we will, and otherwise see if it actually turns on. If it turns on, I don't know why it was advertised as dead, but possibly whoever did this vertical replaced 81720, maybe they didn't know what they were doing, so we'll find out. Let me pause here. I'll grab another 5000 and I'll do some comparisons here with this stuff, and then I'll come back and we'll get it hooked up and see what's going on. Alright, so I grabbed another, I have a bunch of donor boards laying around, as you probably heard me shuffling through over here off camera, but I have another one with a perfectly intact connector here. But if we look, it looks like somebody has done some mods with the jumpers. Now, this is not the same connector. Someone has replaced this connector with a different style. It doesn't have the lip on it for, you know, keeping it secured. It's a different style. It doesn't have the lip on the edge. But if we compare them here, you can see that somebody, well, let's get it all in frame here. You can see that someone has, for some reason, taken these wires here. Let's say 1, 2, 3, 4, and 5, and they're together. And if you look here, 1, 2, 3, 4, and 5 are also together. So that's correct, but why do they have this on here? But look in here, we got brown, and then we got 2 and 3 are together. 2 and 3 are together, and 2 and 3 are together, but they're both in the spade terminal for some reason. 4 and 5 are together. 4 and 5 are together. 1, 2, 3, 4, 5. 6 and 7 are together. 8 and 9 are together. Yep, and then nothing's in 10. 11 is the red wire. So it's wired properly. Ugh. I got my cold snack over here. It's wired properly, but I don't understand what in tarnation is going on with these spade connectors. So I'll just leave it for now, I guess. Let's look. Some of these sockets are kind of laying flat, like they're not making a good connection in there, but I don't trust some of these. I wonder if I can... Oh, come on. Where's my driver? I just had it to do just those color pots. Blah, 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 blah. Well, I don't know where the darn thing went. Oh, there it is. So sometimes you can do a little cheating here by pushing these in. If we... Some of these are kind of flat, and I don't like it. I imagine like this one here is kind of flat in there. And I need to remove it, which we can just do that, and it should come right out. This one here. Now I need to bend that in a bit more. There we go. And voila. Okay, see, what I'd have done it when I replaced, if I was to replace this connector, I would take these and just bend them out slightly like this. And also take, since this connector burns up a lot from bad connections, I would take your fiberglass pen and clean the contact here. And look at that, nice and shiny now. That is nice and shiny compared to the, see how oxidized that looks, and then this side is nice and shiny now. So yeah, that's bend it out, clean it up, and then put it back in here. First you have to take a little knife like this or something and bend the little lock back up. That's why you don't want to push it down too far. Just take your blade and bend the lock back up slightly, and there you go, just like that. Then we'll put it back in the connector thusly, and locks in, and that's much better. See, look at this now. If we look in here, this is the one that I just fixed compared to, like, look at that one. It's pushed back. This one's out, that one's pushed back. This one's going to be fantastic. So I'm going to go through here and do all this before we power it up. I'm going to do all these connectors, what I did to this one, and I'll come right back. Then we'll hook this up, and then we'll get it going. and see what happens. I'm half tempted to just remove all of the pins out of this connector on this one and replace this one with this one. As a matter of fact, I may just do that. You know what I should do? Will make this a lot easier now that I think about it, is just remove the red wire, remove the brown wire, and just replace this entire thing with this entire thing and make it about 10,000 times easier. I didn't think about that till just now when I picked this up. If we look at this one, let's look at this one. Oh, sorry. It's hard to see in there. Let me look in here in person. Those are kind of pushed back. Well, let me see what I can do. I'll decide what I want to do here off camera and I'll get it done. When I cut back here, I'll have it complete and we'll show you what I did. Here, hang on. Alright, so what I decided to do was just keep this original connector because I don't know what's going on with these. I don't want to disable this and put a different one on if someone needs this for something. I don't know. But we verified that everything is jumpered out correctly and it should work. And I also went ahead and removed this burned up connector with all the bad header pins and just decided to use the extra connector, one of the extra connectors from the donor board here. Took this one off and I soldered it in here. So now we have two good connectors for what we need for this chassis. And the back side here, I did some reflow and rework. I actually removed, sorry about that. I removed all of the original solder for the 15 kilohertz side and reflowed the 15 kilohertz in the brand new solder joints. And yeah, that's correct. Okay. Looking through the viewfinder, thought I had missed this one. Hang on. I got to get all that crap off of there. Hang on a second. Where did we go? There we go. Now that's better, but get all this crap off of there. There we go, that's better. So anyway, I got all the original solder off and put all brand new solder on, and all this side here as well. And someone had, I mentioned before, it looked like somebody had used super glue on the back side of the neck board here for all these transistors. And this is the same thing here, is somebody used super glue to try and hold those these loose header pins in from the burned up connector. Let's see, these loose header pins. Someone tried to super glue them in place so they didn't go down or up and down in the solder joint. So yeah, that was interesting to figure that out. I had to get all that, dig all that out with the tweezers here, and that was fun. But as you can see, we're now good to go for our video header selection pins, and everything is good, nice and shiny, good solder joints, everything is perfect. So that's what I did. I replaced that connector, and I got all of the contacts out of this, cleaned them up with the fiberglass pin, bent them out so they make better contact. So now this is all done now. That's all I've done. I have not touched up any other solder joints, done any other testing or any other further analysis. But everything we've done so far shows us that it should power on, but will have vertical collapse. So let's hook up the tube and see if that hypothesis is correct. Okay, all hooked up. Anode, neck, yoke, ground, video, power, remote board. We're set up to read our B+. The test point is right. This is falling down there. The test point is right. Can we see it? Not from this side. Right there. There is a little header pin, and you can see there. It says B+ right there by the horizontal yoke. There's a little test point right there I'm clipped onto. That's test point 202. That's where you read your B plus from on the U5000. And yeah, so we're assuming it's going to power on. So we're looking for it to power on, and we're also expecting it to be collapsed. So we're expecting that. And I'm also expecting B plus to be around 115 or so based off of our light bulb test. And unfortunately, the B plus pod is so covered in glue that I'm not going to be able to adjust it. I may have to replace it if I need to take it up to 117. But let's see if it turns on, and if we do in fact have collapse. All of our tests indicate this is what we should get. So let's find out. Here we go. 1, 2, 3. It does indeed fire up, and we are indeed at 115. Yep. And we are indeed collapsed. So we are 3 for 3 on our predictions. Oh man, that's bad. So I guess, so let's turn it off. 115 and a half is actually probably okay for testing and operation. Should be 117 ideally, but I'm not going to be able to adjust it. So let's see if we can make it look good and operate properly on the 115 and a half, and probably just have to keep it at that because I don't know if I have any other pots to replace that B plus pot with. It's just a 1K pot. I'm sure I could find one, but I think 115.5 is going to be close enough to 117 to allow operation. So we'll see. But for now, yeah, let's get that vertical IC changed out and do some more testing and see if that IC is the only thing that needs replaced, and kind of go from there. So here we go. Okay, so I have removed the shorted IC, the shorted vertical IC, and I have a brand new one here. Get out of here, stupid wires. Brand new one. I actually have a stockpile here of 4 of them, which if you include this one, 1, 2, 3, 4. So I also mentioned the quickest and easiest way to check to make sure that your vertical IC is good is checking D603, and that's this diode right in here by the vertical IC. It's this guy right here. So if we read the way it's supposed to be, negative lead this way, positive that way on your diode checker, we should have a diode. There you go, 0.5. If we swap our leads around, it should be open. There you go. So that's the quickest and easiest way to test. If you read the diode, it's 0.5 the correct way and 0.7 the opposite, or if it reads a diode drop on both directions, your IC is bad. So let me show you how to read this properly. We tested it in circuit, and pin 5 is the ground, but pin 6 is also shorting to ground, and that should not be. So if we zoom in here a little bit, let's just go there. All right. So with our ground on the frame here, and we go 1, 2, 3, 4, 5. That should be our ground to the frame, and it's open. So we're missing the ground. And then pin 6 should not be shorted to the frame, and it is. So if we go to the good one, 1, 2, 3, 4, and then 5 should be the ground to the frame. That's good. On this one, 1, 2, 3, 1, 2, 3, 4, 5, open. 1, 2, 3, 4, 5, good. 1, 2, 3, 4, 5, 6, shorted. 1, 2, 3, 4, 5, there's 5. 6, nothing. So that's a goner. We'll place that up there, and we'll get this one installed. But before we do, I don't think there's anything on the chassis that's shorted. If we go back to our pads, and we go to ground, 1, 2, 3, 4, 5 is the ground. Pin 6 is open, so that's good. So I think with this burning up, I think that's what took out the IC, and the fact that they had the vertical sweep, they had the 15 kilohertz, the white wire was hooked up to the pin when it shouldn't have been, coupled with the connector burning up, I think that took out the vertical IC. What's interesting though is I just fixed it on the on August 17th of last year. But you know, with this being burned up and everything like that, I'm not surprised it took it right back out again. So let's get this installed, and we'll check it again in circuit, and we'll see if that fixes it. There's that. Again, you only need this just snug like that. You don't need to tighten the crap out of it. So let's zoom back in here and do a little soldering. Okay. Well, they don't stick up very far, do they? That's not. It's a brand new. It's a brand new IC. How come that's not sitting down that far? There we go. Push the little daisies and make them come up. Push the little daisies and make them come up. All right, that's better. Okay. So we got this one. And come on. There we go. You gotta be careful when you're doing this not to create any bridges, especially if you're doing this in Madison County. Alright. And this goes to pin 4, just like so. Let's get that. Alright. Okay, I do believe that is a successful install. Let's double check from a different angle. Yep, seems okay. Let's test to make sure we're not shorted again. Okay. 1, 2, 3, 4, 5, and 6. Good to go. 7, 8, 9, 10. All right. Assuming we don't have any other. I don't know if this operated after the cap kit or not. Assuming that we don't have any joints that are bridged and everything is hooked up the way that it should be. Let me look at something here. I'm curious about that. So that should be, let's see, you got those two. I'm just trying to see if this is supposed to be attached to these right there. Well, wait a minute. They've got something going on here. That cap is supposed to be across here and here. Those two, they've got it jumpered to where it's not supposed to be. Look at this. I'm glad I checked that. If we look here, they have, this is a capacitor. This leg and this leg are a capacitor. And there's another component here. This pad goes to this component. This pad's independent of this. If we look at this one, you can see here that you have this capacitor here, and there's no jump, there's no connection between these two pads and this. It's not there. This trace comes through and goes to these. These are independent of this capacitor. These two legs are independent of everything else. But on this one, they've got those two legs jumpered over to here. Someone's a dingleberry. So we're gonna have to fix that. That should not be like that. Let's get rid of all of this. This could have been why the IC got taken out, I can't say, but this should not be like that. You just solder those together and call it good. There we go. Let's get rid of this. And the person that sent this to me sent me that note that said possible shoddy work, and they were right. So I don't understand why they did it this way, but we'll just leave it like that. That should be okay, and that's this capacitor right here. Right there. That one. So I think That should be sufficient. Alright, that's better. Now the question is there anything else on here that they did like that? I don't see anything. And I have no idea if the joints are good. Like I said, I didn't do any other testing. But with fixing that and the vertical IC being good now, I bet it'll be okay. So let's get it on the tube and test it one more time. If it works, then I'll go through and do a full reflow and a full inspection and anything else that needs done. Then we'll test it one last time and call this complete. So let's see. Okay, let's try again. We don't have anything hooked up for the B+. We already know that's 115.5 or so, and it should jump up to about 116 or so once we get an actual image going. I mean, I'm sure 116 it's operational. It shouldn't be an issue, so I'll probably just leave it at that. But of course, ideally, it should be 117. So there's all the burn stuff and the bad IC. And we're all hooked up for anode, neck, yoke, ground, power, video, and remote. So nothing left to do it. Nothing left to do but to do it. Is that right? I don't know. All right, so here we go. 1, 2, 3. Comes right on. What do we have? Well, hey, no more collapse, but it looks like garbage. Very interesting, and it's kind of fading. Brightness down, contrast down. Let's turn up our flyback. We have flyback control, but that's all the way up. There's focus. Down till the raster lines go away. Brightness. No brightness control. No contrast control. I have no brightness control, no contrast control. I have nothing. Oh, no, that's not good. Let's turn our flyback back up. Well, we don't have collapse, but what about, it's jumping around. And let's do vertical hold. Vertical size. I have nothing on vertical size. Height, oh yes we do. Okay, there's height. Okay, that was vertical position I was moving. Okay, what about width? Are we out of focus again? Sorry about that, guys. The stupid camera. There we go. Width, I have width control, but this is very bad. No brightness, no contrast. Something is very wrong here. So let me poke around, do some testing, see what I can figure out, and I'll come right back. Well, I'm on the handheld version here instead of the overhead because I found a problem. I'm not really going to dive too much more until I get this redone here, but again, just like almost every other one, R811, it usually resides right there, and those two open holes right there is completely open. You can see that I have the two leads here, yellow and black, going right to my meter leads, and it is open. So we have another R811 that's completely open and dead. So I had to, let's get that out of the way, I had to dig through my bag of old school resistors and get a kind of a Frankenstein deal going on here where I have a couple of these in series, and with these two in series, it's supposed to be between 50 to 100 k ohm depending on the revision of the board, but you can see here with these two resistors in series here I get 62k, almost right in the butter zone. So I'm gonna have to install this and then try again and see what we get. If I have brightness and contrast control and adjustment, but it's still kind of hazy and messed up, we'll keep going from there. But the first step is to get this in here and see what kind of difference that makes. So let me do that. We'll get it back on the tube and see what happens at that point. Well, a lot of time has passed since you just saw, and some very interesting things have occurred. So I put the new Frankenstein R811 in there that we saw with the two resistors in series, and that works fine for what it is. But I turned it on and I still had the same problem. I had to have the flyback maxed out, and brightness contrast control did nothing. So based off previous experience, you should never have to have the flyback cranked all the way up to get an image, to get raster. So based off of that, I knew there had to be something wrong with probably my heater voltage. So I turned off the overhead light
and my neck was dark as hell. I had no heater voltage, basically zero, and I had, you know, nothing. So if you look at it now though, I got nice, bright, beautiful heater voltage. And that's because I had to replace the flyback. I put a brand new flyback in, there's the old one, a brand new flyback. And it was very obvious that the flyback was bad because of the non-existent heater voltage and no neck glow and all that. So I had high voltage, I had power, we saw an image, although it was very faint. I had to have it cranked all the way up. No brightness, no contrast. So I knew that the flyback was most likely bad. So I put a brand new one in there, and now it works fine. And I'll show you the image here in a moment. But there's a couple other issues. When I finally got it up and running, and I got an image, it was horribly scrambled, and it making a high-pitched noise. And I went to adjust vertical hold, and I got that to lock on, but it was still moving left to right and scrambled left to right. So I went to adjust horizontal hold, and I'm like, wait a minute. Where's the pot? There's no pot. On the U5000 and the U2000, the horizontal hold pot is on the remote board. On the 7400, 7500, it's located on the chassis, right back here by the U701, I think it is. Yeah, right by U701. There's the horizontal hold pot's like right there, or up here somewhere. But on the U5000 and the 2000, it's located on the remote board. So somebody had the wrong remote board installed. They had the 74, 7500 remote board installed on a 5000, so that would never have worked anyway. So fortunately, I had a spare remote board, but it was just like that one. It was only for a 7400, 7500, but I was able to find a 5K pot and get a 5K pot installed and soldered onto this board. And this was just for testing. I'll probably swap this one out over to that one since it's an original Wells part. But I went ahead and put one in on this one because I want to keep this as a spare for myself if I need one for 74, 7500. But this is just for experimentation. I wanted to see if it worked with this one in case there wasn't something else wrong with one of those. But after getting all this done and verifying that it's good, let me show you what the image looks like now. I have an overly blue image and it won't lock on horizontal. The overly blue image is most likely a shorted transistor because I can turn the blue up and down all day long and it doesn't do anything. It's always blue. I most likely have a blue shorted transistor. Now if I adjust the horizontal hold here, you can see that it does kind of work. Where's my vertical hold? There's vertical hold. So you can see there that it works now. And I say this because it wasn't working a minute ago, and it's just my luck. But I know what the problem is. When I first tried this, I could not get the horizontal to lock on no matter what I did to save my life. I could not get the horizontal to lock on. And I knew it wasn't a problem with this. And so usually I know that when there's sync problems with these chassis, it has something to do with U701, whether it's the image is jumpy or shaky or flaky. There's something either bad around U701 or something bad with U701 itself. And if we look at this capacitor right here, we can see that the corner of it is busted right off. And it's exposed to the elements. And if I actually touch this capacitor here, watch the screen here. I'm going to touch it here. Oh, let me zoom out. Okay, I'm going to touch this capacitor. That it's losing sync. All I'm doing is just touching this capacitor that's broken and the inside elements are exposed. All I'm doing is touching this. And you see how I lose my there, see, now it's gone. This is what it was doing before. I lost my horizontal sync. Oh, and now it's back without doing anything. So we have another broken component here. I can touch it and make it lose sync. Okay, see there, it's lost. Now if I try and adjust my sync here, I can almost get it. See, I can almost get it, but not quite. And if I readjust or touch this capacitor again here, let's get it there. Now I can adjust. There you go. See, now it's locked on again. So yeah, I just know from previous experience when you have sync issues or jumpy images or things like that, it's something to do in this area with that chip. And sure enough, that capacitor was busted. So I need to change that capacitor out. I need to change this potentiometer over to that remote board so I can keep this new one for myself. And we need to figure out if it's a shorted blue transistor or if it's something else down here that's shorted that's causing that. But I'm pretty sure it's a shorted blue transistor. So otherwise, yeah, we have a working image now, and it was all due to a bad flyback. So far we've had a bad flyback, a shorted vertical IC, some burned up and bad header pins for the video selection. We had an open R811, and that little green resistor looking device there is actually an inductor. It's L701. Oh, sorry. It was busted in half, and I'm not sure, you can even see how discolored it is from the heat damage, and it busted right off, and it goes right here next to the HOT. It's this little inductor right there. Come on, camera. That right there. So it goes right next to the HOT. So yeah, we've had a bad flyback, 1, 2, 3, 4, 5, 6 different issues so far, and if we count this one, 7. So 7 different bad components or issues totaling so far. We're not done yet. We may end up with an eighth issue. So they're stacking up. So let's get this capacitor replaced. Let's see if we can figure out why we have a shorted blue color, and then come back, and then if it works and we get everything dialed in and adjusted, we'll switch over to 25 kilohertz and test that side. So stand by. I'll get this swapped over to that, and we'll get this changed out and troubleshoot the blue, and I'll come back. We'll see what we have. So stand by. All right, so let's get first things done first. Let's replace this pot here. Let's take it out of this one. Come on. There we go. Okay. So we'll put that back where that went. Now we'll have to fix these. This off of here. Get this installed. Oh, okay, there we go. And put it about halfway. All right, now we have a proper U5000 remote board. I overlooked that originally, and that's kind of my fault, but ultimately no harm was done. I knew there was a horizontal hold problem because it was making a high-pitched squeal when I turned it on first after changing the flyback out. So I knew we had a hold problem, whether it was vertical or horizontal. I adjusted vertical. I was able to get it to lock vertically, but it was still scrambled left to right like you saw previously. I went to adjust the hold. I'm like, wait a minute. It's the wrong one. So we got that fixed. Let's try and tackle. Well, you know what? Let's take this apart first. But before we start working on it, let's replace this broken capacitor. And yeah, if you look at it, the corner of it is broken, and it's exposed to the outside elements, and it's no longer able to do what it's supposed to do. So we'll set that with the rest of the bad parts. And let's grab our donor here and steal it off of this one. And oh, it's already open. Well, that's convenient. And with these film caps, the film caps aren't polarity specific. So you can put it in however you'd like to do it. There we go. Stay in there, knucklehead. Ah, maybe it's not. Okay. There we go. Alright, that should take care of our hold problem. And earlier when after I had replaced R811 and it didn't work, I went through and inspected every pad, every trace, checked every continuity joint from all the caps that were replaced, and I didn't find anything wrong. And I went through and did a basic reflow. I didn't do a complete full reflow. I just hit the spots that looked bad and just trying to get it up and running again. I thought maybe it might have been a bad joint or something, but I went through and hit all of the points that I thought might have needed it. So I'll go through and do a full, complete, total reflow that is more involved after we get this up and running. But the most important part, of course, is always your video header pins, because those are always burned up. Case in point. So, yep, I think if we want to count this cap that was soldered over to the other place where it shouldn't have been as another issue, so far we're up to 1, 2, 3, 4, 5, 6, 7, 8. 8 issues so far. And if we figure out this overly blue image problem, we'll be at 9. It's been a long time since I've had a chassis with that many issues, but this one is approaching 9 issues. So let's test and see if our blue transistor is shorted. Okay, diode mode, I believe it's 0.6 and 0.6. That's our red. 0.6 and 0.6, that's our green. Here's our blue. 0.6 and 0.6. So that's not it. I don't think so, anyway. So here we go. This will be fun. When you have all blue, all red, or all green, it can be one of these 3 resistors. It can be one of it. Well, let's say it's all blue. It could be the resistor. It could be the transistor. It could be the resistor inside of here. It could be the inductor next to it. It could be U5000. It could be one of these 3 transistors here. It could be something on the main chassis. So there's lots of problems that could be the cause of an overly or all one color image. So the next step would be to test the 2.7K resistor. Usually if the resistor is bad, you'll have no color on that side. We'll test it anyway. Should be 2.7 ohms. Yep. Let's make sure that our blue cutoff pot isn't broken, which I did earlier, and it's not. So, yep, and our resistor's good, so it's not the pot. The transistor checks good. We can throw another one in there, but it reads the way that the other ones do. Let's try it this way. See, I don't think that will give us a reading in this. 0.6, open. 0.6, open. 0.6, open. So yeah, I don't think we have a bad transistor. It could end up being that, but I don't think so. Just based off of our testing. So let's test our inductor. Inductor's good. Let's test our resistor. I think it's around 270 ohms, something like that. No, I'm wrong. 150. 150. 150. So it's not the resistor. Let's test our diode here. The Zener diode. Diode's good, but it's not a busted pot. Let's move on to these transistors right here. I don't know which one is for which color. Wait a minute, I'm not doing this right. Okay, 0.6 and 0.6, 0.6 and 0.6, 0.6 and 0.6. Interesting. Let's try it another way. Let's try it with the middle. 0.6, 0.6. Is that how I just did it? 0.6, 0.6. Let's try it this way. So those all read correctly, or the same. So it's not any of these. It's not the resistor, the inductor. We didn't test Q. We didn't test this transistor here in front of it. Let's go to here. 0.7 and 1. 0.7, 1. 0.7, 1. Huh. That's interesting. Why do we have all blue? I mean, it could be something with the main chassis, but I don't think so. It's hardly ever something with the main chassis, unless, you know, I didn't reflow. Like I said, I didn't do a full reflow. I normally always reflow the header pins for the remote cable and this cable on both ends. But I haven't done that yet. I mean, it could be that, but it's hardly ever something on the main board. I wonder if we just simply... we won't have any blue if I remove the transistor. I wonder if we just throw a new one in. Let's just throw a new one in and see what happens. The inductor is cracked here. That inductor is cracked. We can change that out. I've got another board here for just this type of occasion. I tell you what, let's remove the blue transistor. It goes red, green, blue. It's red, green, blue. Let's remove the blue transistor and change out that inductor that's broken and just see if that makes any difference here, because yeah, I can't find anything wrong. I mean, it reads correctly. Now, I've had these be bad before where they read correctly and actually they're bad. So, I mean, it could be open. I can't say. Let's test it out of circuit. Let's take it out of the circuit and test it out of circuit. How about that? Because it could be reading something through one of the other components. All right. Let's grab a known good one here. I got brand new ones here. Just gotta find them. Where, oh where have my transistors gone? Oh where can they be? I had them, here they are, I found them. I'm not finishing that song. Okay, so I got a whole bunch of brand new ones here. Let's test this against a good one. Okay, if we go to, well, that's a, of all these ones that were in here, that's a spare one that I robbed from another board. All right, here's a new one. So let's see. If we go to the base, that should ring to the center. Yep, so we can go. So we got 0.6, and the other leg is open. So if we go here, we got 0.6, other leg is open. So I don't think it's the transistor. We can change it out anyway, but I don't think it's a transistor. Like I said, I mean, that makes sense because everything else is reading properly. So like if we were to read this one here that I have for spares, and we go to this and go here. Do I have one in there? I do. Let's just go to this one. 0.6. Oh, now that's interesting. 0.6, 0.6. But if we go this way, 0.6 to 1, open to the other. We go here, 0.6 to 1, open to the other. Isn't that what we already read? 0.6, open to the other. Well, let's just put this one in here. And see what we get. Because I didn't find anything else wrong. There we go. Let's make sure that our height is correct before we solder it in. That seems good. Of course not. There we go. Okay. Now, we got a brand new one in there. Let's see what we get here. Negative on the middle, 0.6 to 1, nothing to the other. 0.6 to 1, nothing to the other. 0.6 to 1, nothing to the other. Well, we didn't find anything else wrong, and if we had a bad pathway or trace, it would be no blue, not all blue. So with the new one in there, and not finding anything else wrong, the pot's not broken. These transistors were all good. Let's change the inductor real quick. That's going to be this guy here. I mean, it tests good, but I don't trust it. Although if it works now, I don't know if it was the inductor or the... If it works after doing this, I don't know if it's the inductor or if it was the resistor. I'm sorry, the transistor. Okay. Come on. There we go. So it's out. And let's rob this one. Make sure it's free. There we go. Let's straighten out the feet. And let's get it in here. There it is. All right. Okay, well, let's get it all hooked back up and see if we still have a shorted blue image. It's not the tube, so don't worry about that. I mean, in reality, I don't know what it could be other than the transistor, because everything else checked good. So let's find out. Here we go. Okay, it's turned on, it's running. We changed out the blue transistor, and nope, still blue. But I did notice this. If I tap on the neck board, watch what happens. We temporarily lose the all blue. We temporarily lose the all blue image by tapping on the neck board. So it's probably got a cold solder joint with all the bad heat damage. So let's reflow the entire neck board, see if we can clear this up. Yep, so stand by. Okay, so all the neck board rework is now done. I reflowed and cleaned up all of the solder pads. You can see here for the resistors, I cleaned all those up, and so anything and everything that was even closely or remotely oxidized or visually looked like it needed to be reflowed, I reflowed all of the solder joints for the transistors, all of the pots, all of the pads for the U5000 decoder chip, all the joints for the ribbon cable, the main joints here for the neck socket, anything, all the transistors that we checked up here, the smaller ones, you know, up there on the top, you know, anything and everything that could possibly have been the issue. I didn't see anything that jumped out at me like, oh, that's the problem, but you know, everything that was oxidized, even the slightest, I reflowed all of it. So it's all back together now. I just need to plug it in and hook up the ground. And let's cross our fingers and see if this works. If not, I don't know, I'm at a loss. But let's see what happens. 1, 2, 3. Okay, we didn't hear high voltage because it was still charged up. This one doesn't discharge for some reason, so I never actually discharged it when I took the neck off. And yes! How about that? I mean, I knew it was a cold solder joint because we could tap on it and it would go away, so yes, that fixed it. So now we just need to figure out how to get our colors adjusted properly. So let me get the tripod set up here. I'm going to pause, get the tripod set up, and we'll see if we can make this look good. Alright, so let's see what we can do about this. Let's, first of all, our contrast is too high. Let's go right there, brightness. That's not bad. There we go. H position. And width. So we have H position and width control. We have a stable image now after changing that capacitor out. Horizontal hold works. Let's do our height. We have, give me a different picture here. Come on, come on. Vertical position needs to go down, and let's do our height. Okay, so now we have a full screen, and contrast needs to be about there. Well, let's see if we can adjust our colors here. Let's turn this down a bit to roughly, we'll put all of them at 1/4. Let's try our contrast again. Alright, so let's turn up, contrast and brightness are all the way down. Let's turn up our flyback till we get our raster. Oh, well, I keep forgetting that these ones don't give you raster prior to an image. So we'll leave our flyback right there. Brightness, contrast. We're getting there. Look at that. Out of focus, but let's adjust our focus here. Ah, beautiful. What do you think of that? That looks pretty good. And, oh yeah, much better. Outstanding. So it's not going to be perfect because it's not staying on this tube like I say every time, but that looks pretty darn good. So now we need to switch over to a medium resolution game and see how that looks. Alright, so let's turn this off. Let's switch our vertical sweep connector to the black wire that has nothing in it, because we don't want to run the vertical sweep mod while we're in 25 kilohertz. And we'll swap this connector over and verify that I didn't screw something up on the 25 kilohertz side of things. We're going to have to get a medium resolution board here. And there it is. Okay, let's see what happens here on medium resolution. We shouldn't have to adjust any colors. We will have to redo our screen position, size, and everything, so let's turn this on. And it comes right on, and let's see how this looks. Okay, vertical hole right out of the gate. Why do we not have vertical hold? H position. Vertical position. Huh. No vertical hold on medium resolution. Well, interesting. Why is that? Let's turn our light back on. Further troubleshooting is required. Okay, that's no sync at all. Do we have another bad component here? I don't think so. We had vertical hold on medium. Like it doesn't go far enough. Huh. Well, let's see if I can figure this out now. That's why we test. Well, I figured out my problem and it took a bit of ingenuity. This is the U5000 board that I have on the other chassis that I was using for testing earlier. That works just fine. This one here is the incorrect one that came with this chassis that somebody thought would work and are interchangeable, but they're not. We already talked about how the horizontal hold pot was missing and needed to be installed, and that fixed the issue of being able to lock on horizontal hold. But the circuitry of this board, this P804 board, is different from the P718 board. So with the 5000 board and the 2000 board and then the 74-7500 board, they're different. And what the main difference is for the vertical hold, you can see here that there is a jumper that jumpers across from this point to this point. And I've got it cut and going here, and I'll explain in a minute. But if we look at the one that's for the U5000, you can see the vertical hold just goes straight down here to this pin. And there's no jumper across here. But on this one, the center point on that pin for the hold pot goes right to here. And you'll see that it runs over to this resistor, which goes down to here. So if we look at this one again, the resistor is tied to this point on the pot and goes right to this pin. But on this one, it's not. It runs across this jumper and then up over here through to the horizontal hold pot. So the circuitry is different. So, but this resistor still goes to that same leg here, this same point here. This resistor goes to that pin, and this resistor goes to here down to that pin. So in order to correct this, we have to cut that jumper and solder it to this leg of the resistor, because it goes down here to this pin. So in essence, we're tying this point on the pot straight to this pin like it is over here. And after I do that, then I get my full 200K of travel in the electrical part of the circuit. So after performing that mod, I now have the equivalent of a fully functional U5000 remote board, even though it's for a 74-7500. So if you ever come across this problem in the future, if you have a U5000 with the wrong remote board, or you only have access to one of these and you need to use it and vice versa, whatever the situation may be, you're going to have to install a horizontal hold pot, which is 5K, and you're going to have to cut this jumper and run it over to that resistor there. That's what you're going to have to do to mod this in order to have your full range of your 200K in circuit for your vertical hold. So after that has been accomplished, I don't know if I'm going to be able to do this with one hand here. Maybe. I don't think so, though. Oh, dang, flang it. Yes. All right, so that's on there now. So now, with the correct situation set up here, let's go ahead and turn this off, set this up, and watch the magic here. Here we go, 1, 2, 3. Now in theory, it should be locked on. Any day now. There you go. How about it? If we adjust our vertical hold, there, lock on, and we got a lot of range. Yep, I'd say we're good. Turn our brightness down to roughly there. Contrast up slightly. I'd say, yeah, that looks pretty good. Of course, we need to adjust. Everything on medium resolution is different compared to standard. So we know our 15 kilohertz is perfect. It's still going to be perfect because, you know, now I have my full range of vertical hold, but that wasn't as picky about it as the medium resolution was. So if we do H position, that's good. Let's do our width. That's good. Vertical size. That is good. Position. Size. Well, look at that. Hot diggity. Well, there you go. I think that is a working U5000 now. We know the standard res works, we know the medium res works, and I'll let it run for a couple hours and we'll call it a successful repair. So I appreciate everybody watching. Hopefully you learned something. We always do on these things. And like, share, and subscribe. Stay tuned for more. And I will say that I'm going to let this run for a couple hours, take it off, do the full reflow, more inspection, and get it cleaned up and finalized before I send it back to the owner. But like I say, for these videos, it's just the purpose of this is for the repair and the technical knowledge, not necessarily the cleanup and all the stuff behind the scenes. So it's working now, but we know both resolutions are good, everything is good, and I'm assuming it's going to run for a while and be fine. So we'll consider this repaired. Consider it repaired. But I do want to review all of the findings here because I think I tallied it up in my head. I think there's 10 separate issues that this chassis had. I can't recall in recent memory working on one of these or any monitor repair actually where I had 10 separate issues causing various different problems. So let's go ahead and I'm going to take this off of here and I'll do the review and then I'll do this other work behind the scenes. But we'll go ahead and consider this fixed for now. Let's take this off the bench here and let's go through and do a review of all the bad parts and get that going here. So stand by. Okay, let's review. But before we do, I want to say that I went ahead and found a screw, was able to mount the vertical sweep mod to the heatsink like it's supposed to be. So that's done. And again, you want to have the selector hooked up to the pin for the standard res. So the white wire needs to go on the pin for standard, and you need to put it in the empty spot for medium. So since we're leaving it on medium res, we need to put the pin in the empty spot. So that's all done. I'm going to leave this like this because I don't know why this was done, but it's done for a reason. So we put that on there, and of course we got all the rework done to these, the cleaned up. While this was out, I used the fiberglass pin and cleaned up all the pins on the standard res connector too, so that should be good for a good while. Got all the pins removed from the connector, cleaned those up and got them bent out, so the good connection on those. And I think except for cleaning it up and doing a little bit more inspection on a little bit of reflow on the back on some other stuff, the main board is now complete and done and ready to go. Neck board as well. I got all the reflow done for it as part of the troubleshooting and cleaned up, so the neck board is good to go. And yeah, so let's review all of the issues that we found here. We'll start with the remote board. Issue number 1, remote board was the wrong kind. So we got I'm sorry, not the correct kind, but we got this repaired. We got the horizontal hold pot installed that was missing from the circuit, and we got the modification done completed to allow us to have full range of vertical hold ability. So that was issue number 1. Issue number 2 was the cold solder on the neck board. I don't know which joint it was, but reflowing the entire thing fixed it, so we had an all blue image, or mostly blue, or
a shorted blue, something that was causing all blue on the image. It was caused by bad solder on the neck board. We got the neck board completely resoldered, and that fixed the overly blue image. We had a capacitor. This capacitor here, this 250 volt 2.2 capacitor, had a leg that was soldered to a joint that it shouldn't have been. And I think we powered it up that way. I don't know if that did some damage, possibly to the flyback, but that was another problem. So that was issue number 3. Then we had a bad flyback that was causing no, or giving us almost no heater voltage. That was issue number 4. We had the burned up original header pins and video selector connector and everything for the medium resolution. That was issue number 5. We had a shorted vertical IC causing vertical collapse. That was issue number 6. We had a broken C733, this little metal film cap that goes over here in the corner that was causing horizontal hold issues. That was issue number 7. Issue number 8 was a bad R811. It was completely open in circuit, which we didn't find out until we replaced the flyback, or some form of troubleshooting and scenario therein. We found that R811 was open. That was 8, I think. So yeah, 1, 2, 3, 4, 5, 6, 7, 8. Issue 9 was the broken inductor that was right here next to the HOT, this L704 right there. And then I don't think this inductor was actually bad, but this one that was cracked and missing pieces of it and whatnot on the neck board that I thought was bad. So I can't really call this issue number 10, but it was an issue. So I think that was it. Is that it? Yeah, we had the cold solder, the cap that was soldered incorrectly. We had the wrong remote board. That was 3 different issues. I'm including the pop missing and the mod that needed to be done all as one. So that was 3 separate issues. Flyback was 4, 5, 6, 7, 8, 9. I thought there was a 10th one. I thought there was a 10. I thought there were 10 issues with this, but I guess not. Well, I don't know. Let's just say issue number 10, being very dirty. We'll call it that. But anyway, 9 or 10 different issues. That's the most issues I've found on any given chassis that I can remember. So this is a long video. Thanks for sticking with it all if you didn't fast forward through it. But I'm glad to get this up and going. The U5000s can be notoriously difficult, but don't let it intimidate you. It's not that hard of a... It's not really much different from the 74, 75, 2000. It's the same exact thing. There's just more to it for the dual resolution, but most of the important things are all the same across all 4 of those chassis. So yeah, I mean, if I did forget something, no big deal, but I think that's pretty much everything. So again, thanks for watching. Like, share, and subscribe. Got a lot more stuff on the way, and I appreciate it, and we'll see you then.